I'm going to talk about immunology and a fantastic orchestra. And I want to emphasize that we don't know all the players of the orchestra and all the instruments played by the orchestra. But there is one thing that we know, and that is, and this is mentioned in papers, and just a second, yeah, here it is. And that is that immunity is a meta-narrative of modern medicine. In other words, that it connects things that include infections. And here we were wrong. This is an essay that was catalyzed by David Farmer, and I was part of it. Here we were wrong. We should have said acute and chronic infection. Then lifestyle, exposure to environmental. I heard about psychiatric problems, and the connection is with cardiovascular diseases, with, of course, autoimmunity, with depression, with neurodegeneration, and senescence. So the fundamental tenet is that immunity and inflammation represent a meta-narrative of modern medicine. And although I will discuss specific aspects related to cancer and then to COVID-19, I will mention data that emphasize this general connection. So macrophages play a key role in inflammation, and more so in chronic inflammation. And if you are interested in a short review of modern views on inflammation, you may have a look at this review that Mihai Netea catalyzed with a bunch of us, and I was part of this effort. So macrophages and cancer, and this is actually my connection to inflammation. And I want to emphasize the key contribution of this guy, Bob Evans, at the time Chester Beatty Institute, Cancer Research Institute now. And Bob is the one who actually first showed that macrophages in tumors are bona fide normal cells. They are not tumor cells in disguise. And he and Peter Alexander also showed that appropriately activated macrophages could kill tumor cells. And I will get back to that. I had the privilege of working with Bob and Peter early on, but my views diverged. I started working on metastatic tumors, on human tumors, and found that macrophages were actually promoting tumor growth. And actually in work that was mentioned, and I thank Ricardo for mentioning it, early work done in my lab, we found a chemokine that turned out to be MCP1, CCL2, that was produced by tumor cells and attracted macrophages, as we had predicted based on this result. So the general picture that emerged was that, and is that now generally accepted, of a reciprocal ping-pong symbiotic interaction between macrophages and tumor cells, whereby tumor cells attract these corrupted policemen, and these in turn promote tumor progression by providing growth factors, by promoting angiogenesis, infiltration, and by taming adaptive immune responses. So macrophages are plastic cells. Plasticity is a hallmark of mononuclear phagocytes, and this is macrophage plasticity as depicted by Vasily Kandinsky. And you can see the classically activated M1 macrophages, the ones described by Evans and Alexander as being able to kill tumor cells. An alternative form of macrophage activation, and this was originally described by Simon Gordon in Oxford, and then variations on this theme. And I should say that we had a bias that the tumor-associated macrophages be M2-like, but when we did the first transcriptional profiling of tumor-associated macrophages, we had a phenotype which was somewhat in between. And I will get back on this at the end of my talk, sharing my very recent results on the diversity of tumor-associated macrophages. So again, plasticity. So inflammation and cancer are connected, and macrophages have served as a paradigm for the connection between inflammation and cancer. And we like to think and schematize this connection as consisting of two pathways. And this is work that we did together with Fran Bolquist, a review that we wrote in Nature. An extrinsic pathway whereby genetic events that cause cancer induce the construction of an inflammatory microenvironment. And this is the intrinsic pathway. And the extrinsic pathway whereby inflammatory conditions, for instance, inflammatory bowel disease, predisposes, increases the risk of developing a tumor. And for a long time, our focus on the tumor microenvironment was on cells. But work that was done in my lab by Eduardo Bonavita, and we have, I should say that we have a story in press in Nature Cancer that I will not discuss. This work done by Eduardo strongly suggested that components of the humoral arm, so here is the cellular arm of innate immunity, components of the humoral arm of innate immunity complement this molecule, and I will get back to this molecule that we cloned. These molecules are very important in shaping the tumor microenvironment and cancer-related inflammation. And of course, as we all know, we have moved from a cancer cell-centric view of neoplasia, as was originally crystallized by Hanan and Weinberg, to one that encompasses inflammation. That was my own crystallization, and this is the new view of the hallmarks, where inflammation and immunity is there. Actually, I feel that this is not a real representation, because I think that innate and adaptive immunity and inflammation should be close together. They are close together, and they are double-edged swords. And I will get back to this general concept in my talk. So this work of mine and of ours is part of a long trajectory, of a dream. The dream of using the tools of immunity to fight cancer. And this Polarlic, for instance, is here. And of course, this is the adaptive immunity trajectory, the innate immunity trajectory. Of course, I was associated with this one. And this is for the young people. For a long time, there was not much, oncologists did not have much credit to the idea that immunology could actually have an impact on cancer management. And of course, now we are living the era of immunotherapy. Again, inflammation, my own emphasis has been on the tumor microenvironment, the two pathways, and the inflammatory cells and mediators, but there is a connection at a systemic level, including obesity, a cause of cancer, aging. Of course, here I have a vested interest, a general paradigm of inflammation, lifestyle, diet, physical exercise, and there is evidence that the inflammatory tone is a key determinant connecting at a systemic level these risk factors for cancer to the tumor microenvironment and tumor promotion. So back to the tumor-associated macrophages, you can think of tumor-associated macrophages, again, a paradigm for the connection between inflammation and cancer, as being a double-edged sword, and being shifted in a pro-tumor direction, because by signals coming from tumor cells, from stroma, from adaptive and innate immune cells. These cells are oriented to immunosuppression, for instance, in many tumors. I heard the presentation before on breast cancer, where PD-L1 is essentially expressed on stromal cells, macrophages. invasion, metastasis, stroma, response to hormones and drug. We should not forget that. So the challenge is translation, including prognostic significance versus predictive significance, prevention, interception. I'm going to briefly touch upon all these points. I will get back to this later. So, long time ago, there was only one cytokine associated with innate immunity inflammation, and that's IL-1. And so it was natural for us to get involved in IL-1. And so we contributed to dissecting the complexity of the IL-1 system. For instance, we identified, as Ricardo nicely, and thank him for doing that. Remember, we originally identified the type 2 receptor as a decoy, cloned one of the receptor antagonists, and originally cloned, we were the first to clone, this fringe member of the family, which we now call IL-1 R8. And then we worked on the link with TLRs. So our hypothesis was macrophages promote tumor growth, a bit actually countercurrent at the time. So early on, Raffaele Giavazzi, at the time in my lab, asked the question, does IL-1 promote tumor growth? And actually, Raffaele found that IL-1 promoted dissemination and metastasis under many conditions. And this was confirmed, extended, for instance, by Fernando Vidal-Vanaclocha and Charles Dinarello. And Ronnie Apte did seminal work because he put these observations on a firm genetic background. So is this relevant to human tumors? And I go back to the concept of a meta-narrative of modern medicine. This is the CANTOS trial. This is an atherosclerosis trial. Paul Ridker is the main investigator of this work, together with Peter Libby and others. So an atherosclerosis trial, but they looked at cancer, and these are more than 10,000 patients, and they found that treatment with an anti-IL-1 beta monoclonal antibody was associated with a remarkable over 60% decrease in the incidence and mortality from lung cancer. So this long 30-year pathway calls on the one hand for confirmation and extension. There is an issue. I think that there is an ethical issue to conduct an interception trial, a prevention trial. There is a lot of discredit for this type of trials, and we're making an effort to have one. So we have a duty to test whether we can interfere with carcinogenesis in subjects at high risk by blocking IL-1. In addition, it calls for mechanisms, and this is our current view. IL-1, on the one hand, is a driver for macrophage infiltration, which are general promoters of tumor growth, myeloid cell-mediated suppression of adaptive immunity, and endothelial cell activation. And this is actually where we started originally in those experiments. And this is actually an introduction to the second part. In other words, in this, one of the genes that we had that we originally cloned, IL-1 R8, is a fringe member of the family, a negative regulator, a component of the receptor for an anti-inflammatory cytokine, IL-37, largely forgotten anti-inflammatory cytokines. And it acts as a checkpoint, if you pass me the word, for NK cells, and we have unpublished data on some T cells as a checkpoint, and blocking this checkpoint unleashes, and this is work of Martina Molgora, unleashes the anti-tumor activity of these innate lymphoid cells. So again, back to macrophages, the challenge is, can we exploit macrophages? And of course, there are two options. One is block the corrupted policeman. For instance, work that we did on a drug that was developed in Spain, and Maurizio D'Incalci is the pharmacologist at the Mario Negri Institute, and we found that the killing of macrophages is a key component in the anti-tumor activity of this drug, which has been approved. On the other hand, PD-L1, of course, is expressed in tumor-associated myeloid cells, and it's the dominant pathway of blocking adaptive immune responses. And then there are checkpoints. There are myeloid checkpoints. And here is one, CD47. CD47 is a don't eat me signal. It is upregulated by oncogenes, by MYC, and work that was done by Ir Weissman and others, and the clinical trial is at Vani, and this is our editorial, has shown that blocking this checkpoint, myeloid checkpoint, unleashes myeloid cell-mediated anti-tumor activity. And the work of Advani provides evidence that this pathway may result in anti-tumor activity in diffuse large cell B-cell lymphoma. So we stick out our neck, and perhaps this is the opening of a new era, myeloid checkpoint immunotherapy. I'm going to share with you some data concerning again, shifting the balance and interaction with myeloid cells with innate lymphoid cells. And as I understand, there may be young people listening, and this is a story. I'm not going into the detail. Andrea Ponzetta is the main character, and Sébastien Jaillon in my lab. And this is a story that popped up from an unexpected observation in mice. And in essence, we found what we believe may be a novel pathway of anti-tumor resistance, which involves a tripartite interaction between myeloid cells, neutrophils, macrophages, and unconventional double negative T cells with innate-like properties. And there are people in Barcelona who are better expert than I am on these receptors. And we found that this pathway is relevant to resistance to MCA, methylcolanthrin carcinogenesis, and correlative evidence in human sarcomas. And again, this is a general message. We are doing single cell analysis, and this is the section of single cell analysis of a minute population of double negative T cells infiltrating murine sarcomas, so the complexity. And then a model, correlative evidence. This is undifferentiated pleomorphic sarcomas, and this is in silico bioinformatic analysis, and this is wet analysis in a cohort of our patients. So the challenge is we are doing single cell analysis 20 years, like in this painting, French painting, and the challenge is to move from pointillism to Eiffel. So to get a model, I think, and to reduce the complexity to working models, useful working models. So I mentioned neutrophils. Neutrophils are the brothers of macrophages, small brothers of macrophages, and we stumbled in neutrophils several times. I just want to remind you that there are a number of myeloid checkpoints expressed in neutrophils and macrophages, and with some differences between neutrophils and macrophages, and these may be interesting therapeutic targets. And this is a patient with an acute phase reaction. These are the nuclei of neutrophils, and this is the neutrophil alphabet. This is a molecule that we cloned. I'll get back to that. And the general message I would like to leave you with is never underestimate the power of a neutrophil. Again, I assume that there are young people listening to me, and I want again to share a story, again related to the interaction between myeloid cells and innate lymphoid cells, with a message, with two messages. Well, this is the story that started from transcriptional profiling of the first transcriptional profiling of human monocyte to macrophage differentiation and polarized activation. The work done was done by Fernando Martinez, a talented, fantastic PhD student from Cuba, and supervised by Massimo Loccati. Massimo is now independent, but at the time he was in my lab. So among the genes that popped up, there were members of a family of genes, and here it is, tetraspan-like molecules. And there is one tetraspan-like molecule that all of us know, and that is CD20. And of course, monoclonal antibodies against CD20 have changed cancer therapy, have changed therapy of autoimmune diseases. But the family includes many members of unknown function. And one that we picked up actually turned out to be exclusively expressed in macrophages, unknown function. So the general message I want to leave you is that about 20–25% of the information encoded in genome, we don't know its significance, its function. So there is plenty of room for discovery for young people. So it's called the ignorance. So we decided, well, it's expressed in macrophages, we should understand what it does. The paper, Irene Mattiola, she's now at Max Planck in Germany, was the main person in it took, let me go back. Again, I want to leave a message to the young people. We discovered this gene reported in 2006, and we have published the paper in 2019. And it took more than 10 years, and we didn't publish a paper for a long, long time. And the reason why we didn't publish a paper is that we wanted to understand. I think that raises a general issue of mechanism of funding high risk, I think high gain research entering the ignorance, for instance. So this is the message of the study. This molecule interacts with other innate immunity receptors. We have identified one, the first one, the actin-1, and others have identified another one. It localizes in repeat rafts, and it provides a milieu for optimal signaling. And of course, we have long known that actin-1 is important for antifungal resistance. What we are interested mainly in cancer, and capitalizing on old work done by Tada Taniguchi, and we reproduced, I mean, again, message for young people, you want to have reproducible data. So we reproduced Tada's data, and then we had the knockouts, and but the pathway had been identified by Tada Taniguchi. So this pathway is essential for recognition of tumor cells by recognition of N-glycans, and triggering of anti-metastatic resistance by interaction between macrophages and NK cells. And Miguel is there, perhaps he's there, and he knows much more about NK cells than I do. So this is the general message and scheme. It's the tentative scheme. Of course, innate immunity contributes to original elimination together with macrophages. In non-metastatic tumors, you still have a pathway of resistance against metastases mediated by the interaction between NK cells and macrophages. And this glycan recognition pathway, at least in preclinical models, is indeed important. We have some clinical evidence, correlative evidence as well. And progression is associated with loss of this pathway of resistance and escape and metastasis. But I emphasized that immunity and inflammation represent a meta-narrative of modern medicine. So this is our story. We discovered the function of a member of the ignorome, a tetraspan selectively expressed in macrophages. In parallel, we have data together with Costantino Pizzalis. Ricardo mentioned my connection to London, to Queen Mary. In parallel, we have data on rheumatoid arthritis. But the strongest genetic association is with neurodegeneration. And there are many more papers. And this is a question mark. So again, the same molecule, different human diseases. I'm checking my time. I think I still have time. And of course, this is, well, you know the painter. I would like now to share with you some recent unpublished, well, they're just out in data. These are tumor-associated macrophages in metastases, liver metastasis from colorectal cancer. So the pathology, one day came to me and said, and the surgeon, Matteo Donadoni is a surgeon, they came to me and said, look, there are macrophages here stained, but they have very different morphology. And of course, I had known for I don't know how many years that different macrophage population have different morphology. So the question, is morphology relevant? So we worked out, or they worked out a system based on machine learning and the actual bioinformatic approach has been just submitted for publication to quantify macrophages with different morphology. And these are essentially, and these are the separated cells, the big ones and the small ones. And early on, we had some indication that this was associated with outcome. So this is serious, more than 100 patients. And you can see if you use a marker, CD163, which is generally associated with an M2-like phenotype, no impact on outcome, prognosis. But if you quantify small and large macrophages, then if you have small, the number of small, well, the quantitation of small macrophages is associated with much better outcome. Let me remind you that here the surgeon is a problem because he can cure about 1/4 of the patients by surgery of metastasis, but he would like to know who is at risk. And this turns out, odds ratios are here apparently the best prognostic indicator. And if you quantify at the invasive margin, again, same story. So why is that? So, of course, we did a transcriptional profile and found, I'll go quickly, that a correlate is lipid metabolism. Then, of course, we have done single-cell analysis. I believe that this is perhaps the first single-cell analysis of macrophages associated with human metastasis, and found, again, remarkable differences between the small and the large macrophages. And so this is the take-home message: liver metastasis, clinical problem, surgeon, pathologist, immunologist together. The small macrophages associated with some kind of anti-tumor activity, presumably. The pro-tumor macrophages, the large, what we define, the large macrophages with a profile associated with lipid metabolism, complement, back to complement, and the balance between the two, and this is the prognostic significance. And I mentioned the editorial by Peter Murray because we and Peter, it's a beautiful essay, speculate that perhaps these are the incoming fresh monocytes and these are the tissue resident cells that seed the tissue. and expand in response to tumor. That's speculation at the moment. So in the last few minutes, I think I still have some minutes. I would like to move to COVID-19. And this is the virus as seen by 3 of my 8 grandchildren. It's not a bad representation of the virus because here is the spike protein. So when in our region in Lombardy, we were confronted with the virus at the end of February. Actually, the virus had been circulating since January. And of course, at that point, as Ricardo said, I went back to my Greek Latin roots, to Socrates, and I realized that I didn't know, and we didn't know. By the way, if any of you is interested, we have a report on immunology and vaccines by the Accademia, the Science Academy of Italy, the Accademia dei Lincei, which is available, and 2 of us draft this report. So this is my summary of the interaction between the virus and the immune system. So the virus, of course, interacts with the upper respiratory ways. The interaction, the outcome of the interaction is dictated by viral load, by inflammation, by lifestyle, by genetics. And this is a paper, and my institution, we did, I think, one of the first, if not the first, genetic analysis of the human population. And based on that, then we moved to a large cooperative studies, and we were together. We were together. That's fantastic. And again, I want to emphasize a message for the young fellows. This is the Manhattan plot from that study. I should mention that the main character there was Stefano Duga and Rosanna Selt, the real geneticists. And this is the Manhattan plot, chromosome 3, the Neanderthal connection here, and chemokines receptor genes, so very dear to my heart, and inflammation. And here there is blood groups, and this is not, there is a story in a Prime journal. The revised version is in Prime journal, large cohort, very large UK cohort, and this is not coming up. So again, data are data. This is solid, confirmed. This is, I think, still question mark. But this points to genetic predisposition and inflammation. And of course, the only drug that we have that has changed mortality are glucocorticoids, if they are given at the right time. And again, this was an effort, and I really enjoyed the presentation of your task force. This was an effort by Maurizio Cecconi, also was involved in the confirmation of the original study done by Horvi et al. And published in the Lancet. Innate immunity, of course, we're interested in innate immunity, and we're interested in these pathways here. And again, genetics, and again, I'm proud to quote work that involved Valdebron, and inborn immunodeficiency. And this is the work, the leaders of the work were Jean-Laurent Casanova and Luigi Notarangelo, brought studies. So you know this work very well. But I want to emphasize the general message. And the general message is that COVID-19 is at the intersection of autoimmunity here, but also autoantibodies that promote thrombosis, similar to antiphospholipid syndrome and autoantibodies. So autoimmunity, genetic predisposition, the effort that we did together, the chromosome 3 effort, immunodeficiency, here it is, and uncontrolled inflammation. And I want to share you some recent results on uncontrolled inflammation. So a molecule that I already mentioned and that Ricardo was kind to mention is one of the genes that we cloned is this molecule called Pentaxin 3. We cloned the mouse and the human cDNA and genomic and characterized the promoters, and we have a structure and more. And the reason why we focused on this molecule is that here in this exon 3 has a definite relationship with C-reactive protein, which all of us know. So we felt that this may be a component of humoral innate immunity that would help us and shed some light to the logic of humoral innate immunity and actually to the role of C-reactive protein, which all of us use. By the way, C-reactive protein is a pentamer. The molecule that we have identified is an octamer. And it's a family of long pentraxins. And we have cloned another molecule. And we have not published, well, we have published the paper, but we are still working on understanding what it does. So here is the molecule. It behaves as a functional ancestor of antibodies because it recognizes microbial components. It has opsonic activity via Fc gamma receptors. It regulates the complement cascade, and it has a regulatory function on inflammation. And again, I want to emphasize my link to Barcelona because this is work done by Andrea Perutti, and we have made a minor contribution to this work, showing that indeed this innate immunity molecule links to adaptive immunity. So we've done what everybody is doing. We've done RNA-seq of PBMC in our patients, and PTX3 popped up as being very high. And then we looked in silico and physically in peripheral blood, in the alveolar, in the lungs, in the alveolar spaces. And here it's monocytes, the cells that express very high levels, monocytes, macrophages, and neutrophils. In the tissues, these are autopsy specimens. This work was done in collaboration with Giovanni XXIII Hospital in Bergamo. In the autopsy specimen, it is expressed by various cell types, but for instance, in particular, endothelial cells surrounding, for instance, a thrombus. And we had actually cloned the gene also in endothelial cells. So we have an ELISA assay, and this is the data. The work was done by two clinicians and Barbara Bottazzi in my lab. And it's the Humanitas task force. And so we measured, and the bottom line here is these are 96 patients, and the endpoint is a hard endpoint, it's death, and 28 days death. And if you are in the upper tertile, you have, and this is shown here, the hazard ratio is 22. And here is the estimate of the impact of the increase. And Giovanni XXIII had a second cohort, 54 patients collected at the very beginning, not very standardized, but the same general message. In addition, there is a third independent cohort. We are not involved in that study of 75 patients in southern Italy with identical results. So this is an independent prognostic, a predictor of death, independent, and apparently better than anything else, including IL-6. So this is the message of this work. Again, here are the main characters involved. A distant relative of C-reactive protein, PTX3, is produced by many cell types, by myeloid cells, presumably triggered by the virus, I guess, by cytokines. It is produced by endothelial cells, and I think that the merit, we think that the reason why it is such a strong prognostic indicator is that it integrates myeloid cells with endothelial cells. And downstream of this molecule is recognition of microbial components, complement, regulation of inflammation, and these are question marks, I should say. The end result is it is a novel biomarker with strong prognostic significance in 3 independent, albeit small, cases. Final comment on vaccines. These days it's impossible to talk about immunology without mentioning vaccines. It is depicted as a race, and again, as Italian Academy of Science, Accademia dei Lincei, we have a report which we update, the 2 vaccines, the 3 vaccines which are the front runners. I just want to move to global health for a second, and this is my representation of vaccines. I hope that the vaccine will have complementary functions. A few months ago, we were told that Africa is polio-free, and this is because we have 2 vaccines. And if we want to live in a world polio-free, we need a 3rd dose. We need a 3rd vaccine, with all the difficulty of having a 3rd vaccine against polio. Vaccines, of course, we know they instruct adaptive immune responses, but they also, some vaccines also elicit what has been referred to as pathogen agnostic protection. In other words, for instance, BCG vaccination, measles vaccination elicit protection against agents that are unrelated to Mycobacterium tuberculosis or to the measles virus. And the mechanisms are likely complex, but include activation of myeloid precursors or mature macrophages. Mihai Nete and I was invited to write this essay for New England because of some Neanderthal work, some prehistoric work that I did on this. And Mihai actually defined the epigenetic landscape and remodeling, which underlies what he defined trained innate immunity. And this epigenetic remodeling results in increased microbial killing, cytokine production, fluid-based pattern recognition molecules such as the anti-antibodies such as Pentaxin 3, which we cloned, and activation of adaptive immunity. And there are, of course, prospective studies with BCG in COVID-19. I think that for the time being, an open interesting question is whether the vaccines against COVID-19 actually result in better immunological fitness of the immune system. So in training of the innate arm of the immune system. Vaccines, before COVID-19, 3 of us, Rino Rappuoli, an eminent vaccinologist, Angela Santoni, an immunologist and K-cell expert, and myself, the 2 of us have been involved in the Global Alliance for Vaccines and Immunization. We had a paper in JXMed, and our tenet was and is that vaccines are an achievement of civilization, a human right. So this speaks to equitable sharing of vaccines, and we should not forget that 1 kid out of 5 who is born on this planet does not have access to the most elementary vaccines. And vaccinology and immunology represent our health insurance, the safety belt, if you pass me the definition, for humanity, for the future. And I think that the COVID-19 epidemic has borne out these affirmations. And finally, we are close to New Year, and we are going to have wine, presumably, fantastic Spanish wine and Italian wine. There is an Italian wine called Gavi. Well, Gavi also is a global alliance, the Global Alliance for Vaccines and Immunization. I have had the privilege of serving in the Gavi Alliance for 5 years, and immunologists have been part of the Gavi Alliance, now Angela Santoni. And Gavi is at the forefront now for equitable sharing of the COVID-19 vaccines. Once more, our cultural roots. I know that I don't know. And this is the premise for knowledge. And of course, SARS-CoV-2 has reminded us that nature is fond of hiding herself. But we, immunologists have taken the challenge, and as in this painting of Lucio Fontana, we are taking the challenge to go across the cuts and understand what is behind. So this is a group picture of us at work, the junior people in the lab, the senior people, and this is the senior people are these three ladies, and this is my contribution to the work. And I hope that I did not forget to mention the people who have actually done the work. And this is the funding, and this is the institution. And once more, it's really a privilege to be with you today, and I hope to be back in Barcelona soon.